when they're talking about making a prediction, they've already figured a probability that something would happen. And in this particular problem, a car rental company sells accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase insurance? They've already figured the probability of people purchasing insurance. What's the probability? 24%. Okay. 24% is the probability that the event would take place. We want to predict how many times out of 550. Please take the time to underline or circle this phrase where it says 24% of its customers.
Multiply.
Of mathematically means multiply. So, if I look at mathematically what this phrase means, it's saying 24% times the number of customers, 550. But we don't work with percentages as percents. What do we change them to?
Decimal.
How many places do I move the decimal?
2 times to the right.
2 times to the left, 0.24 times 550.
Equals 132.
That 132 represents the number of people that they expect to get what? Accident insurance. That's what it represents. So we're using probability to make a prediction about what's going to happen. Okay? In the real world, this is how people purchase products for the year or for their month. They look at data that they've accumulated. Even McDonald's, they wouldn't order a whole bunch of chicken nuggets if they weren't going to sell a whole bunch of chicken nuggets. They use data, they figure out the percentage of people that normally come in to purchase it. They figure out about how many people they normally have, and they purchase according to that. Okay? Then they have extra, and that's always a risk. And when companies end up with extra, short of McDonald's, but you're almost any place where you stop to buy clothing or anything else, what happens? The price goes down. They put it on sale because they've got a surplus of something that they need to get rid of. By the way, at the end of the year, what happens with manufacturers of automobiles? The new car goes what? Up, and the old cars go down. They're trying to get rid of 2015 and restock with 2016. Okay? Okay. Everybody understand how we did this problem? We all good? Can I move on?
Yeah.
You'll find this one on page 388. In emails to monthly readers of a newsletter, 3% of emails come back undelivered. The editor predicts if he sends out 12,372, he predicts that he's going to receive 437 of them as being undeliverable. And it asks, do I agree? Well, the first thing I've got to do is make my own prediction. How do I predict how many are going to get returned? Okay. 3% as a decimal. How many places do I move it?
0.02.
2. 1, 2.03 times what?
12,372.
12,372. Okay. 12,372 times 0.03. So, I predict $371. Anybody want to tell me why I dropped off at 0.16 in this problem?
Of the one.
Okay, very good. If it needs to be represented as a whole, right? I can't get part of an email sent back to me, can I? They're going to be whole emails. So, with that being said, if it should be counted as a whole, like a person, we don't have 3.5 people in class. We either have 3 or we have 4. If it needs to be a whole, count it as a whole. If this would have been 371.5, I would have rounded it up to 372, but I'd have still counted as whole pieces. Everybody understand that part? Now we're going to compare. What did he predict? His prediction was
A lot more.
437, which was
Only 100.
too much. His prediction was too high. It was too high by
66. A lot. More than 5. By 66.
He was 66 more than he should have been. Everybody understand that sometimes we've got to make a prediction and we've got to compare it to something that they've already predicted. And when we do that, we're just seeing, hey, is their prediction reasonable? Or was this prediction too much or too little? But the process of us predicting didn't change, did it? It even uses the same phrasing, 3% of the customers, 3% times some number. We all good? 390. Okay, you're just going to wait a minute. Have a seat when we're done with the lesson. On average, 24% of the customers. Notice the phrasing again. What does it say? 24% of. In other words, 24% times the number of customers. 24% of the customers who buy shoes in a particular store buy 2 or more pairs. One weekend, 350 customers purchase shoes. How many can be predicted to buy 2 or more pairs? So they're asking me to predict. That's the first question. It says, if 107 customers purchased, did more customers than normal buy 2 or more pairs? So they want me to compare the 107 to my prediction and decide if that was more than usual or less than usual. Okay? 24%. 0.24 times 350, the number of customers. 0.24 times 350. We predict that 84 customers should buy 2 or more pairs. So what if 107 customers did? We predicted 84 would, but they had 107 that actually did.
So it was.
They said, did more buy 2 or more pairs than normal?
Yes.
Yes, because there was 107. So in fact, how many extra people?
A lot. 20 something.
23.
33. I got 20.
There was 23 extra people that weekend then that purchased 2 or more pairs of shoes. Everybody get it? Well, good? Okay. That's the homework, but what are we going to do before we do the homework?
Mastery
We're
test.
going to take our mastery test.